Here we have a calculus problem on finding critical numbers of a function. There is a function given over here, and we have to find critical numbers for this function. Okay, whenever I want to find critical numbers for a function, I need to find the first derivative of the given function. Once I get the first derivative, it has to be equated to 0 and solve for x. Okay, now let me take the given function as it is. It is f of x equals to x to the power of 4 over 5 times x negative 4 the whole square. Okay, f of x equals to, okay, before I find the first derivative, first I have to simplify the stuff on the right side of the given function. So x to the power of 4 over 5. So we can expand the square of the binomial over here. When I expand this one, I'm getting x square negative 8x positive 16. So using the algebraic identity, that is a minus b the whole square, we can expand this one. Okay, now so now in the next step, what I need to do is I have to distribute this x to the power of 4 over 5 to this one, and this one. So let me do it. So f of x equals to, when I distribute x to the power of 4 over 5 to this x, so here we multiply two terms with the same base x. So whenever I multiply two terms with the same base, I have to take the base ones and add the exponents. Then I'm getting 4 over 5 positive 2. Okay, this is the product rule of exponents. So when I distribute this x to the power of 4 over 5 to this term, so again we have x over here, here we have x the base. So and also we don't have any exponent for this x. We have to assume there is exponent 1. So when I multiply this one and this one, I have to take the base x ones and I have to add the exponents. Let me do it. Negative 8 x to the power of, I have to add these two exponents 4 over 5 and 1. So 4 over 5 positive 1. And when I distribute this one to 16, I'm getting 16 times x to the power of 4 over 5. Okay, let me continue over here. F of x equals to x to the power of, okay, now we have addition of a fraction and an integer. So whenever we have addition of a fraction and integer, and we have to multiply the integer part by the denominator of the fraction 5. So once I'm done with this multiplication, I can take this denominator 5 as a common denominator. So I'm getting 4 positive 5 times 2 is 10 over 5 negative 8 times x to the power of. So when I add so the fraction and an integer, the same thing. So I have to multiply this integer 1 by this denominator 5. So then I'm getting 4 positive 1 times 5 is 5. Now I can take the 5 as a common denominator, positive 16 times x to the power of 4 over 5. Okay, now let's do further simplification. F of x equals to x to the power of, so when I simplify this fraction, I'm getting 14 over 5 negative 8 times x to the power of. So here when I simplify this one, I'm getting 9 over 5 positive 16 times x to the power of 4 over 5. Okay, that's all the simplification I can do in the given function. So now what I can do is I can start finding the derivative of the given function, that is f prime of x equals to, okay, to get derivative of the first term over here, I have to use the power of the derivative. That is, I have to bring this exponent 14 over 5 in front of the variable and subtract 1 from the exponent. So then I'm getting 14 over 5 times x to the power of 14 over 5 negative 1. Negative. So here variable is multiplied by the constant 8. So when I find derivative, there is a constant multiplied by the variable. I have to keep the constant as it is and find the derivative of variable alone. So again, I have to apply the power rule. That is, I have to bring this exponent 9 over 5 in front of the variable and subtract 1 from the exponent. So positive, we can keep the constant 16 as it is. When I find the derivative of this part, so I have to bring the exponent of 4 over 5 in front of the variable and I have to subtract 1 from the exponent. So f prime of x equals to 14 over 5 times x to the power of. So here I do subtraction between a fraction and an integer. Now we have to multiply this integer 1 by the denominator of the fraction. So 14 negative 1 times 5 is 5. Now I have to take this 5 as a common denominator, negative. So 8 times 9 is 72 over 5 x to the power of. When I simplify this one, I'm getting 9 negative 5 over 5 positive. So 16 times 4 is 64 over 5 x to the power of. When I simplify this one, I'm getting 4 negative 5 over 5. Okay, let me do further simplification. F prime of x equals to 14 times x to the power of. So when I simplify this one, I'm getting, when I subtract 5 from 14, I'm getting 9. That is 9 over 5 as exponent. 9 over 5 as exponent for x over 5 negative 72 times x to the power of. When I simplify this one, I'm getting 4/5 over 5 positive 64 times. When I simplify this one, I'm getting x to the power of negative 1 over 5 over 5. Okay, so f prime of x equals to, okay, in this expression, so there are 3 terms which contain x. So here the exponent of x is positive. Here also the exponent of x is positive. but here the exponent of x is negative. So now we have to make this exponent as positive. For that, I have to move this term to denominator. So whenever I move a term from numerator to denominator or denominator to numerator, so the exponent, the sign of the exponent will change. So here already it's a negative. So when I move this term to denominator, so the negative 1/5 will become positive 1/5. So our aim is to make this exponent as positive. Let me continue. 14 times x to the power of 9 over 5 over 5 negative 72 times x to the power of 4 over 5 over 5 positive 64 over. So now I move this term to denominator, then I'm getting 5 times x to the power of positive 1/5. Since this is moved to denominator, the exponent, the negative exponent is changed to positive. Okay, now let me continue on the next page. This is the last step we have had on the previous page. Okay, now I have to simplify the expression we have on the right side. Okay, so for that, I have to look at the denominators of each fraction over here. So here the denominator is 5, here the denominator is 5, here the denominator is 5 times x to the power of 1 over 5. So only if I have the same denominator for all the three fractions, I'll be able to combine the three terms over here, the right side of y prime of x. Okay, for that, I need to multiply both the first fraction and second fraction by x to the power of 1 over 5, because here 5 is multiplied by x to the power of 1 over 5. Okay, let me multiply both numerator and denominator by x to the power of 1 over 5. And the same thing in the second fraction, that is I multiply both numerator and denominator by x to the power of 1 over 5. Okay, now let me write the next step. F prime of x equals to, now 14 times, here we multiply two terms with the same base x. So whenever we multiply two terms with the same base, we have to write the base x once and I have to add the exponents, that is 9 over 5 positive 1 over 5 over, when I multiply these two, I'm getting 5 times x to the power of 1 over 5 negative 72. So here again we multiply two terms with the same base, that is x. So we have to take the base ones and we have to add the exponents, that is a product of exponents, that is 4/5 positive 1/5 over 5 times x to the power of 1 over 5 positive 64 over 5 times x to the power of 1 over 5. Okay, f prime of x equals to, now for all the three fractions, we have the same denominator, that is 5 times x to the power of 1 over 5. So that can be taken as a common denominator. Now let me write the numerator of the first fraction, that is 14 times x to the power of, okay, so here we have addition of two fractions, the same denominator 5. So we can take the common denominator 5, we can add the numerators 9 positive 1 negative 72 times. So x to the power of, we have addition of two fractions with the same denominator, we can take the common denominator 5 and we have to add the numerators 4 positive 1 positive 64. So f prime of x equals to 14 times x to the power of, so here 9 positive 1 is 10, then we get 10 over 5 and negative 72 times x to the power of, so here 4 positive 1 is 5, then we get 5 over 5 positive 64 over 5 times x to the power of 1 over 5. Okay, let me continue over here. F prime of x equals to 14 times x to the power of, when I divide 10 by 5, it's to negative 72 times x to the power of 5 over 1, 5 is just 1. So whenever there is an exponent 1, we don't have to mention. Okay, then we have positive 64, everything divided by 5 times x to the power of 1 over 5. Okay, now I got the first derivative. That's all the simplification I can do over here in the first derivative. Okay, now what I need to do is I have to equate this first derivative to 0 and solve for x. Okay, let me equate the first derivative to 0. Then I'm getting 14 times x squared negative 72x positive 64. Everything is divided by 5 times x to the power of 1 over 5 equals to 0. Okay, now I have to get rid of this denominator. So for that, I multiply both sides by 5 times x to the power of 1 over 5. Okay, let me finish writing 5 times x to the power of 1 over 5. So here on the left side, this one and this one will cancel out. I'm getting 14x squared negative 72x positive 64. So when I multiply this stuff by 0, it will become 0. Okay, now I have a quadratic equation. Okay, so when I look at the numbers over here, everything is a multiple of 2. So when I divide everything by 2, the numbers will become smaller. So it will be easier for me to solve this quadratic equation. So let me divide so each term in this equation by 2. So when I divide 14 by 2, it will become 7. That is 7x squared negative. When I divide this 72 by 2, I'm getting 36x. When I divide 64 by 2, I'm getting 32. So when I divide 0 by 2, it becomes 0. Okay, let me continue on the next page. Okay, here we have the quadratic equation 7x square, negative 36x, positive 32 equals to 0. So we can solve this quadratic equation either by factoring or quadratic formula. Okay, let me try to factor this quadratic equation. So here the coefficient of x square is 7. So to factor and solve this quadratic equation, first I have to multiply the constant of 32 by this 7. When I multiply this 32 constant of positive 32 by positive 7, I'm getting positive 224. Okay, now I have to get two factors for this positive 224, so that the product of the two factors equals to positive 24 and the sum of the two factors equals to the coefficient of x negative 36. So I think negative 8 negative 28 will work. So when I multiply negative and negative, it will become positive. 8 times 28 is 224, and also when I add negative 8 and negative 28, it equals to negative 36, which is the coefficient of x. Okay, now to get the values of x for this quadratic equation, what I need to do is I have to divide so both the factors by the coefficient of x square, that is 7. So let me divide this 8 by negative 8 by 7, this negative 28 by 7. So here 7 goes into 7 one time, 7 goes into 28 4 times. So the resulting stuff will be negative 8 over 7 and negative 4. Okay, now to get the two values of x in this quadratic equation, I have to change the signs of these two factors. Already it's negative 8 over 7. If I change the sign over here, it will become positive 8 over 7. And if I change the sign over here, it will become positive 4. So when I solve this quadratic equation, I'm getting two values for x, 8 over 7, and the other one is 4. So these two numbers are called critical numbers. I equated the first derivative to 0 and solved for x, and I got these two values. So these two values are called critical numbers. Okay, now we cannot decide immediately only these two are critical numbers. Apart from the two critical numbers, what we got over here, 8 over 7 and 4, so we have to do one more check. What is it? Let's go to the final step of the first derivative. So this is the final step of the first derivative. Okay, now what I need to check is so whether this f prime of x becomes undefined for any real value of x. Okay, in this f prime of x, if I plug in x equals to 0, what will happen? If I plug in x equals to 0, the denominator will become 0, because here the denominator contains x. When I plug in x equals to 0, the denominator over here will become 0. In a fraction, if the denominator is 0, then the fraction, the value of the fraction is considered to be undefined. So that is f prime of x becomes undefined. So x equals to 0 makes f prime of x undefined. So that x value, that is x equals to 0, also should be considered as critical number. So now for this function, we have three critical numbers. Already we got the two critical numbers, 8 or 7, 4, and the third critical number is 0, which makes f prime of x, the first derivative, undefined.